So now that we've mastered our sedimentary rocks, we're going to dig a little bit deeper here, thinking about igneous rocks. So with sedimentary rocks, hopefully you have that keyword in mind, sediment, right? Rocks that are created from these small pieces of other rocks. Well, that's that category of rock type. Here, with igneous rocks, the keyword we want to be thinking about with igneous is like volcano or molten, or this idea of magma, lava. Those key ideas, those terms are what we want you to think about as we move forward with igneous rock. So the characteristics we saw before aren't going to show up here. This is a whole new category of rock type. Just like sedimentary, we do want to know how they form. So we've got a process section and then a couple keywords, intrusive and extrusive, to get to know. So not a lot of notes happening here. So stay tuned for another lesson about classification and observing the rocks down here. So starting out with the process for an igneous rock, here's what we want to know, is that these rocks, are coming from this molten magma or hot lava, and they're cooling and crystallizing to become the rock that we see today. So these rocks over time go from this molten state into these small crystals, and those crystals are what we can then see within the rock, either bigger or smaller, depending on how they formed. And it really depends where they form to give us an idea of what type of crystals these rocks have. So we do want to make sure we know the difference between magma and lava. So looking over on your right-hand side, you've got this little notes section about the difference between magma and lava. See if you can remember, what the difference is there. What we're thinking about for magma and lava, it's all about location, where those rocks are being formed. Magma is this molten rock trapped underground. That's our key word here. So you could draw a little picture like this one in your notes, just a quick, volcano, and label underneath. This is our magma section down here. Magma is that molten rock underground, where lava is the molten rock that reaches the surface. Oh my gosh. There we go. So lava is our surface molten rock. So once it exits out of the volcano, it officially becomes lava. When it's inside the earth, it's officially called magma. The only difference is that idea of location, where that rock is at, or the molten rock rather, because they're both still liquid. And so cooling in those different places is what gives us two types of igneous rocks that you see on your title there. We've got intrusive rocks and extrusive rocks. So we want to know a little bit about each one. Intrusive should give you a little clue here with its prefix, the word in. These are rocks that are formed inside of the earth. So they get the name intrusive for being inside. And these rocks inside the earth typically look like this. They're what were called coarse-grained or coarse-textured igneous rocks because of how slowly they have cooled over time. Being made inside the earth, they are from cooled magma. And so that magma is essentially, I like to think about it like inside the oven of the earth. So it cools slow, allowing these grains to grow. And when I'm talking about grains, I'm talking about these different crystal pieces I can see. So the fact I can see each individual grain is giving it the name coarse grained. And again, that's because these rocks cooled so slowly inside the earth. They're kind of protected and slowly cooled inside the earth. Where extrusive rocks, extrusive, we're thinking about exit. These extrusive rocks are cooling outside of the earth, so they earn the name, like we said, extrusive. And here's what an extrusive rock is going to look like. These are our fine-grained rocks. Whereas I can't go back in and kind of outline and point out these little crystals, at least not with my naked eye. If we were to zoom in on this with a microscope, we'd be able to see some very small, fine-grained crystals in here. But for the most part, these are pretty unviewable with the naked eye. And this happens because of how rapidly or quickly these rocks cool as they are erupted from a volcano, meaning they're cooling from lava. They cool really fast. Think about it going from thousands of degrees down here inside the earth to the cool Earth's temperature, 40s, 60s, whatever it is. It's going to cool very quickly. Those crystals don't have time to grow. There's no insulation there. They are simply very, very small to the naked eye. So looking at your notes page here, you've got a picture of two rock types. You should be able to record down which one is the fine grain and which one is the coarse grain here on the list. So on the lines at the bottom, record in fine grain or coarse grained. So when we see a rock on the surface, this is what we're seeing. We're seeing the grain size. I'm not seeing, other clues besides that. And that clue is all I need to get me to intrusive or extrusive rocks. If I look at these grain sizes, I know this took time to grow. This had a good environment to cool in, causing it to cool slowly, meaning it had to happen inside the earth. This is an intrusive rock from magma. Whereas over here, these fine grains, I can't see them with my naked eye. They're very small, so they cooled quickly, meaning they must have happened on the outside of the Earth's crust, or they are extrusive rocks formed from lava. So just this simple visual of fine or coarse grained is really cluing me into the history of this rock. So when we look at our rock samples in our video number 2, that is what we're always going to start with, is what is the grain size. That grain size will clue me into all this information, lava or magma. Every time it's going to be this cooling and crystallizing, and then location, again, depending on that fine grain or coarse grained. So go ahead, check out video number 2 if you're missing the rock lab in class.